Hello, everyone. Happy Halloween. Today we are here on Hangar podcast episode with Bryan Finster. For folks who are joining for the first time, this is a podcast that we run to talk about anything related to developer experience. And Bryan is probably one of the most experienced people I've got to know very recently in developer experience space. Bryan has done a lot of work in Walmart and around continuous delivery. So I'm really looking forward to this conversation. This is going to be a really fun one. So I'm going to start. Bryan, please introduce yourself briefly, and we'll get going from there.
So I've been a software engineer for almost 30 years, coming up on 30 years pretty quickly, actually. Mostly supply chain software. Um, I spent 19 of those years at Walmart, mostly in supply chain. And I was on we had a problem in logistics where we were only delivering once a quarter, hopefully, at a lead time for change of 12 months. And leadership wanted us to fix that. And instead of calling in consultants, they told the senior engineers, go fix it. And over the next couple of years, we figured out the architecture we needed to change, the team structure we needed to change, and started diving into continuous delivery and piloted that capability there. Got our lead time to change down to, on some teams, in many cases, down to less than a day.
Wow.
We were deploying really a lot. Learned a whole bunch. Platform will get you about 10% there. It takes a lot of skill, a lot of teamwork to get to continuous delivery. And then later on we started building a centralized delivery platform at Walmart. And they asked me to come in there and start a team to work directly with other teams to figure out how to solve continuous delivery in that team's context, not just do it our way, but what problems do you need to solve? We were using CD as a lever to improve engineering excellence across the organization. Had the CTO saying we need every team delivering daily because it's hard. I mean, literally, that's why. It's because it's a hard problem to solve, and it brings out the best in everybody when you try to do it. And then later moved to about 3.5 years ago, moved to Defense Unicorns, and we work with the military organizations to help them with the problem of continuous delivery, either with better platforms or knowledge, and also the authority to operate process, which is really a difficult problem to solve.
Wow, that's a lot to unpack. I would love to maybe just start with the fact that you have been at Walmart for almost 20 years.
Yeah.
It's like, there are probably very few people in the industry who can say they've been in a company for this long.
Well, Walmart's kind of special, though. I mean, again, I left like 6 months before I was going to get a permanent discount card. But I still didn't have a gold badge. There's a lot of people I worked with gold badges have been there 25, 30, 35 years. My colleague that we were collaborating most closely on how do we solve the CD problem, he still runs Walmart Cloud Native Platform. I think he's been there like 26 years or something.
Wow. So, I think this is also the era almost like, where software engineering has pretty much like changed entirely. Like I would say even the Agile manifesto came 20, 25 years ago, right? So, like how have you seen the organization evolve? I know obviously like there was these CD efforts that you were doing.
Walmart wasn't my first job. But I tell people that I've delivered with just about every fad people can come up with. I mean, we went from, my first job, it was basically incredibly agile. I was doing customer customizations of a warehouse management product. I'd get on the phone with them. They'd say, hey, we need a new screen or this new capability to meet our business. I'd tell them, it's going to take about this long. And then I was everything. There was, I was the DBA, the BA, the developer, testing. I did everything, and could spin stuff around in a few days and say, okay, is this what you meant? And at Walmart, they, back in early 2006 or something, they ran all the senior engineers and managers through PMI training. So I learned how to be a project manager. and they were trying to really hammer down on project management. That worked great. And then brought in Agile, which was just project management in 2 week sprints, just 2 week waterfall. Then brought in Safe, and that was 2 week waterfall with a bunch of extra jobs we shouldn't have had and several more meetings. And then we figured out continuous delivery, and it fixed it all.
Very interesting. I actually don't even know what SAFE is. Leave that for another conversation because
The scaled agile framework.
interesting. Okay. Okay. So I wanna jump right into our core conversation, continuous delivery, and you're probably the most experienced person in this space. So I'm really excited for this. So let's just start with, how do you define continuous delivery? Is it also different than continuous deployment?
It is.
Because I think kind of like people use the term interchangeably many times.
Yeah, they're not. They're not interchangeable. I mean, they're related, but they're not interchangeable. So continuous delivery is the ability to deliver the latest changes to production. We're always deliverable. That's the thing, is we're always deliverable. The latest change is always deliverable. And it's important. I make a change today. That change could go to production at any moment. Okay. Continuous deploy is that I make a change today, and that change deploys to production. And there's some truth in the thought that continuous deploy is like we have more maturity, quality process is more mature, but it's not always true that that's the case. Every delivery, which one of those you really want to be used really depends on your delivery context. You're not going to be doing continuous deploy to a submarine. It's just not going to happen. You're not going to be doing continuous deploy to a secure, I forget what SCIF stands for, but it's basically a Faraday cage where you're doing development for top secret stuff. That's not going to happen, right? And so it just really depends on your delivery context, which one of those you use.
So, especially if you're talking about deploying to submarines, I think that's a very fascinating example. How would somebody think about continuous delivery for it, right? I mean, you still cannot immediately deploy anything that's built, right? You probably, I don't know, have to park it somewhere.
Well, it has to come back to base, right? Because it's underwater. You can't really deploy software underwater very well. The bandwidth is too low.
Right. So even technically, if you're ready to deploy, you cannot deploy.
Yeah, you physically. I mean, this is the same with your iPhone. Continuous deploy doesn't happen with apps. They go to an app store, and even then, you're waiting for them to get certified before they're available to go. The main thing, though, is how, the thing we want to focus on is, if I can't get immediate feedback on the running thing in production, how close to that production immediate feedback can I get? What can I do to get the quality feedback I need? Because really the goal is to find out as quickly as possible that we have quality issues. Another goal that I really harp on is the ability to fix incidents rapidly, safely. Without having to if you're doing CD correctly, there is no hotfix process because you're always using your hotfix process.
Interesting.
So it doesn't work. If you wouldn't use it for hotfix, you don't use it to do anything.
So does that mean continuous delivery is also then tied very much to trunk-based development?
I was talking to somebody about this earlier this week. And I don't focus on trunk-based development because people have these religious wars about trunk-based development. And I don't care. But to do CD, you have to do CI. Okay. And CI means we're integrating code, that any code I write today integrates to the trunk today. Now, if you want to use GitFlow and do 7 merges to get your code on the trunk today, knock yourself out. But you need your code on the trunk today. And if you go look at minimumcd.org, which is a site a bunch of us put together to help people get started, there's 2 varieties of trunk-based development. I commit directly to trunk, or I use a pull request on a branch that lasted less than a day to get to trunk. And there's reasons why you do either one of those. And again, it depends on your particular context.
Interesting. So you're saying essentially Even if you're doing Git flow, your branches should not be long living.
Yeah, but I dare you to do that because it's not just your feature branch; it's also the develop branch. And of course, if you're going to have a hotfix branch, then you always have to use your hotfix branch to deliver anything. So once you start trimming it down to this is what I need to get onto the trunk, you wind up with either pushing directly to the trunk or using a very short-lived feature branch.
Interesting.
But sure, if you think Git flow is the way to do it, I dare you. But it's not CI if you're not getting today's code onto the trunk today. It's not CI because the goal is just share that code between developers and get rapid feedback. It's not about CI servers. It's about sharing the code.
That's very interesting. So, as a developer, like or an organization, if they're thinking about whether we are doing continuous delivery or not, is there like sort of like a obvious metric or like something that they can look at, which tells them that they're doing that they're CD ready?
Well, and that's the reason we put minimum CD together
Okay,
was to create a list of problems that you have to solve to get to the bare minimum of continuous delivery. Do we have production like test environments? Do we have a single way to get to every environment? If I'm deploying to a test environment from a developed branch, I'm not doing a CD. It has to come from the trunk because we're certifying the artifact, not the code. That's an
interesting.
important distinction. You know, there's just these problems we need to solve to meet CD. The one thing we're still working on the website is explaining why on all of them. That takes work. We all have jobs, but we accept all requests.
Interesting. Do you want to maybe even like give a high level overview of like minimum CD? What was the origin of it, where it is today, and what is the objective?
Yeah, so this was a conference project from several years ago at DevOps Enterprise Summit when it was remote. And several of us had been having conversations on LinkedIn with people who claimed they were doing CD because they deployed on demand and their customers only demanded it once a month. Well, it's you're deployable on demand, not you deploy on demand. And demand could be right now because we have something broken and you can't go and create some special flow. You need to deploy using your standard process. So, or you had people who said they were doing CD because they had, build and deploy automation, but none of the quality. And then they'd go and do it, get people all excited about it, blow things up in production, and then CD would get banned in their organization. And it was really frustrating. So we said, okay, we need to come up with a list of the absolute minimum things that we think you have to have in any context, whether it's to a skiff or cat videos to the cloud, of what this defines continuous delivery. And we were hardcore about it. It took us 3 days to pull the basics together, to pull the site together. I mean, it's been prettied up since then, and more information's been added, but the main page has stayed the same since Dave Farley submitted a pull request and changed one word. And Dave Farley is the author, the co-author of the book Continuous Delivery, so it's got Dave's seal of approval. He's pointed to it and says, "Hey, this is good." So that's what it was. It was really the goal wasn't here's how to do CD. It was if we can get people to solve these problems, developers' lives will improve, and that was the goal.
Kind of related question:
Yeah.
Does CD need to be completely automated? Is there sort of like this whole idea that you should remove humans from the loop entirely, and it should be, well, I guess,
Yeah.
continuous?
Everything downstream of coding should be automated.
Interesting. So what happens
Now,
if you're like deploying once a month still?
you don't manually deploy anything. Now, you
Okay.
might hit a button to trigger the automation if you're not doing continuous deploy. You might say, okay, now we're going to deploy. But that's just triggering the automation. You don't go and FTP things around. The one caveat I would have for that is that there are sneakerware pipelines for things like skiffs and submarines. Well, skiffs, because you're not, there's no electronic communication allowed in or out.
Mhm.
So you might have to have a thumb drive or a CD to go to the last mile. But even then, you want an automated install when you get it in. You don't want people manually installing anything.
Interesting. So
right?
you're
So
saying is the practice still has to be like essentially repeatable. There is like minimum human interaction.
yeah, basically the pipeline is the assembly line of the factory, and you don't
Hmm.
want any human interaction in there means you've introduced variability. And so let me give you an example. When we were doing it early on, we would have, when we were learning how to do this, and not everybody understood the principles. You had a failure in a test environment. Oh, it's a configuration change. Let me just tweak that, and I'll just kick it off from there. No, you start at Git. That artifact, any failure in that pipeline, that artifact is dead. You go back to Git, make the change there, and flow it through. I was having discussions this week also about manual testing as a blocking activity. Now, there's good reasons for manual testing for exploration, usability, but these are not things you use for delivery decisions. They're things you use to inform design and to inform test design. But you do that as an ongoing process all the time. Dog food the application you're using on, harden your pipeline. You also use feedback from production to harden your pipeline. But one of the things on minimumcd.org is the pipeline is it decides releasability 100%. And there's no human involvement in that decision because it's all the rules that you've baked into the code. So it's always repeatable. You're trying to eliminate variability, and humans just inject variability.
I mean, it kind of like also goes to this whole, mindset of fear of deployments, right? I mean, obviously, CrowdStrike also showed a lot of like, what could possibly go wrong in the software ecosystem.
Yeah, I
Uh,
dissected their postmortem, by the way, where there was some shocking deficiencies.
So, like, how should a like organization think about this fear? Like, are there like certain ways? I know probably some of their minimum CD principles also help shed light on that, but are there certain ways through which teams and organizations can help reduce that fear?
Yeah, it's simple. It's really, really simple. Take testing seriously, and test design seriously. It's not enough to throw developers at unit testing and then have a bunch of testers writing huge end-to-end tests that are flaky. When we were starting out, number one, we had a principle that any service in the system had to be independently deployable of any other service, which is harder than you think, because if I have to go and do an integrated test between two or more services to validate this service, and one of these services is down in a test environment for whatever reason, and it's 3 o'clock in the morning, then I can't pass my pipeline without doing a workaround. So how do I make a resilient test strategy that allows me to meet my 3 o'clock in the morning, mean time to recover problem? And so then you start thinking, okay, well, I need virtual services. I need to create tests for the virtual services that run asynchronously to the flow to validate that the contracts are valid with the actual service. You come up with all these strategies for resilient testing. You terminate flake in your tests with extreme prejudice. The tests are the most important thing that you as a product team are developing. And then you build confidence because these tests are reliably stopping problems.
So, I mean, there are obviously like, different types of software. I find that it's a lot easier for organizations to get CD when they're serving like a cloud software, right? You're kind of like hosting on cloud because you can press another button, deploy if there's a
Well, I
bug.
don't think the deploy environment matters as much. I mean, when we were learning to do it, we were deploying to metal at the edge. There's just, it's harder to create an ephemeral environment in metal on the edge. I mean, it would take well, actually, at one point, towards the end, we're using VMs, but even then, it would take a while to refresh a VM. You couldn't just do it on demand. We didn't have that ability. So that's a little harder.
Right.
But most everything else is the same.
I mean, but like if you think about it, right? I love the example of submarines. I'm going to go back there. If you have to install software in submarine, right? There is clearly going to be a delay
Yeah.
on the deployment side,
Yeah.
and there's going to be friction. You can't really call submarines from battlefield back so that we can update the software.
Yeah. You have to wait for a
So,
maintenance cycle. Yeah.
so one is obviously validation is critical, as you were saying, but
Mhm.
like, there's also this like whole concern around like, okay, we need to do a full breadth of tests, whether it's automated, manual, all of it, because upgrading software in a submarine is going to be much harder versus if you were completely working on a cloud product.
I mean, there's be that time delay, up to
Right.
3 months. Yeah.
Right. So, I mean, so from that perspective, it does feel like, if you're doing, if you're thinking about continuous delivery, it's much harder to do that for like a submarine type of machines
Well, I mean, it's,
versus,
it's mostly the time delay, but also you have to invest in your test strategy. And part of that is you're going to have, an emulator of the system that's going to be running on the submarine available to deploy software to for people to use constantly, right?
interesting.
And exercise it. Um, you've got if it's for specific hardware, you have that hardware in the pipeline with automated tests running against it, and then you get it to an environment where people can play with it, staging. So you send it to staging. It's like sending it to the app store. You send it someplace where people can get their hands on it. But even in the cloud, depending on what you're releasing, you might only release it to a very, very small subset of people temporarily while you're getting feedback from that before you do a general release. So it's very similar. But again, it's just engineering. We have a problem. We need to get feedback, and it's not just did we build it according to spec, but is the spec correct? And this is something else people miss out on is they have this assumption that the spec is correct. Now, there's a lot of implications of that. If the spec's correct, then you can trust. Then in theory, you can trust a testing team to test your code against the spec. Except the testing team is going to misunderstand the spec differently from the development team, and the spec is probably wrong anyway. And so you need to engineer your entire quality process to eliminate that uncertainty. And the quality process starts when you start talking about what's the next thing we want to build. It doesn't start when we start coding.
That's very interesting. Okay, switching gears a little bit, durometrics.
Yeah,
So we were talking about like, how 3 out of 4 durometrics points to CD,
yeah.
and you have some opinions on that.
Yeah, what's the fourth one that's not tied to CD?
So, from my perspective, generally lead time for changes also requires running the CI pipelines, possibly code reviews, and then
Yeah, all of that's CD. Now, so there's a different. Again, this is like the difference between CI and CI automation, and the difference between CD and CD automation.
right,
Because there's the CD part of testing, which is all the acceptance testing that happens after CI. When you have a deployable artifact, and we're going to go and hammer more and more tests against that artifact to try to break it. I mean, that's the point of that automation is to break it. But
right,
CD is the entire process from gathering requirements to delivery. And the way I talk about it is you've got CD, which is the entire development lifecycle. And then you have DevOps, which is the entire environment within which those development life cycles live that enable us to move quickly and organize, the culture, automation, lean thought process, the metrics we use, the sharing between teams to accelerate our ability to do continuous delivery. It's the backbone that CD lies on. DevOps is not infrastructure. DevOps is the organization, the way it works. And continuous delivery is the software development lifecycle.
interesting. Wait, so then this is also somewhat confusing because we talk about, in the pipeline, we talk about like CI, CD, right? Where we talk about
In the
CI is your
pipeline, yeah.
integration and CD is the deployment. Do you think that CD is actually continuous deployment and not continuous delivery? Or,
Well, again, it depends whether you have a human hit a button at the end of the pipeline or you don't have a human hit a button at the end of the pipeline. That's really the only difference. But again, that's just the automation. How did those tests get in the pipeline? It's because we used a continuous delivery workflow where we didn't commit untested code. We designed the test before we started coding, so we knew what we were going to be testing for. And so this is all part of the continuous delivery workflow. It's a workflow, and it includes the pipeline. But continuous delivery is everything we have to do to get a good idea out the door and actually find out it's a good idea.
so where does the delivery workflow start?
When we get a request or a good idea or we've discovered a defect.
Interesting. So technically, then that is like closer to SDLC. That is definitely different than my definition before this conversation was about
Well, and
delivery.
I'll give you an example to really enable us to get to the ability to deliver as quickly as we were able to on those first pilot teams. The first thing we had to learn was behavior driven development, which is the conversation that happens where somebody sends a request in and we start decomposing into testable scenarios how that request will work. How will this feature behave? Or how will it not behave? It won't do this. It will do this in this specific testable way, right? And so what did we do? We started with tests. We're in test driven development we haven't touched code. We haven't typed anything. We've gone to a whiteboard and written stuff down and then said, okay, that's what we're doing or not doing. Or we've gone through processes with BDD where we've crossed out scenarios and said, we're not doing this scenario. Imagine the amount of money we save by not implementing that. And that's the process of the first semi-technical process and continuous delivery. We can do it well because that enables you to break things down into thin slices. It gives you a solid basis for what to test before you start doing anything. You have cleaning requirements coming in. I mean, CD, it's a lot of it is communication supply chain. How do we smooth out the communication supply chain so that we have clean information through the supply chain?
So do you think it's more of practice than tools?
Yeah, yeah, and it's that's fundamentally, if you try to implement CD, you'll find out that it's 10% tooling and 90% how we do things, and it requires intense teamwork and discipline, which, by the way, improves morale on the team because number one, we're working much closer together. We've got better quality stuff, fewer incidents, able to try experiments on things and throw them away and not worry about it if we don't like the experiment because everything's small and fast. And so the morale improvement I've seen on team, and the first team we did it on, it was like, oh my God, this is amazing. This is an awesome way to work. And then team after team after team, that's why we put that site together. So make developers' lives better. And I'm using developer more. I mean, just make the team's lives better, everybody.
So I want to switch to kind of like a little bit more on the double click on the practices.
Sure.
So, there are like many different modern practices, especially I think it's a lot of them may be tied to cloud development.
Okay.
But things like rollbacks, things like feature flags, things like canaries, things like blue green deployments. Do you think these are like necessary things for teams to actually get to
Oh, yeah.
the continuous delivery, or these are like sort of like nice to have?
No, they're all against solutions to a problem,
Okay.
right? I mean, is a case statement a nice to have, or is it a solution to a problem? Do you always use case statements? Do you sometimes use like a nested if? It depends, right? But those aren't cloud practices. All of those things were things we were doing on Metal.
Interesting.
We'd have load balance servers. You'd have rack A and rack B, and you deploy to the Linux boxes on rack A, and while rack B is under load, you'd do smoke testing on rack A, switch the load over to rack A, install to rack B, and then load balance it again on Metal. This isn't. I mean, cloud is just somebody else's Metal. You just have to have the engineering in place to solve the problem. Same with feature flags. We hit feature. I mean, those are just environment variables if you're doing the basics. And so you can go out and get a complex system to handle it and do all sorts of scaling and stuff. But if you're just trying to do the basics of I'm going to hold this feature off until I'm ready, I'm going to turn it on, then it's an environment variable. You can do that anywhere. So these are all techniques that you need to learn. And people get afraid of feature flags too, by the way, because they're worried about, it's going to explode all the complexity of my code. Only if you're a bad engineer. It's just engineering. Engineer a feature flag at the highest level you need to control that feature. And then if you no longer need that feature flag, remove it. Or you may need it permanently because some people don't want that feature.
Right.
So how would you design it if some people didn't want that feature? Is I can just, you don't have nested feature flags. I mean, you just engineer things correctly.
So does that mean these things are pretty much necessities for somebody to do continuous delivery.
Yeah, I mean the other option is trying to manage with process, and that's bad. You need to know how to do these things. You're not always going to have these things, but you
Right.
need to know how to do these things. So, let
Have,
me give an example. I have never used a feature flag on a service. I can control that with engineering the API. It's just like this segmented API. No one's using yet. We haven't made it public, and so we're building out a new route. And then when people use it, ta-da! Yeah. Or I have another dependency I'm depending on in my service, and I can build my code so that my code won't actually activate until it sees the response on the payload that says that information is available, and then automatically activates. So is that a feature flag? I mean, yeah, maybe, but I didn't have to go set an environment variable. I just had to write the code to be resilient to change.
so essentially, to rephrase what you're saying is essentially these are practices, and there should at least be some version of this practice that you have a model for if you're trying to get to continuous delivery.
And what I would say is that you need to understand what the delivery context is for this feature.
Mm-hmm.
And you need to plan for delivery up front and not try to figure out how to do it at the end. In fact, if at all possible, you deliver first. For example, you decide you need a feature flag. You say, well, for this, we want to flag this off, and then we're going to turn it on later. What's your first change on that feature? The feature flag. You
Right.
validate the feature flag works, and then you make the next small change. This is the thing that people screw up all the time is they do things the wrong order. What's your first deliverable on a brand new service? The pipeline with Hello World to validate you can deploy. Any code that you can't deploy is waste and risk, right? So if you're always deployable, that means the very first thing I have, feature zero, is my pipeline, my ability to deploy. And so you always focus on operations first. You always focus on release first, and then features.
I want to take like a slightly different angle, which is, Facebook when they started, or for a long time,
Hmm.
their one of their motto was move fast and break things,
Okay.
right? So
Yeah.
there is this whole thought process. Maybe you can still do continuous delivery regardless of what your reliability is like. Do you think that's an acceptable way of getting CD?
That's not what move fast and break things means.
Okay, I mean maybe not Facebook. Maybe it's like startups where things may
No,
not
no, no,
always
it
be
doesn't
reliable.
matter. It doesn't matter because if you're a startup and you're constantly blowing stuff up and you're unreliable, you're not going to be a startup for long, right? Move fast and break things isn't about reliability. It's about the idea. It's get the idea in front of people and find out quickly whether it's a good idea or not, so you can pivot and go to another idea. It's not. It has nothing to do with we're going to deliver unreliable garbage. Or if it is, I mean, that might be the idea. That might be what you want to do. But again, you won't be. You'll lose your customer base pretty quickly, and then you won't be a startup anymore. So sure, do that. No, we focus on reliability constantly because if we're not focusing on reliability and also trying to manage our tech debt, we can't pivot. We can't change directions rapidly. I'm leading a development team right now in Defense Unicorns where we're responsible for building out all the company's websites and supporting all the marketing efforts for the company. And that changes really fast. So, what do we focus on? Reliability, ease of change in the code, reliable pipelines, reliable tests, right? So, the whole point is to focus on the ability to pivot rapidly.
Interesting. I do have one more question, and I think we are also getting close to the time. So, given that we were talking about bad engineers,
Yeah.
what's your thought process behind, especially AI? As like a lot of code is now getting written by AI, and I always think like AI are one of those like bad engineers that you have to really very carefully review their code.
No, they're
Uh,
inexperienced engineers. Uh,
how's that?
so the way you should look at it is you've got a tool that knows a whole bunch of stuff that you don't want to have to keep in your head and can spit out code really fast based off of its knowledge, but it doesn't really know how to build anything. if you get bad results from an AI, it's because you don't know how to use the tool. So something that because I use the tool, and the same skills I found critical for CD are the same skills you need to use an AI effectively. Break things down small, have testable, requirements. You have to be specific. You're coding with language, and then you have to use specific language. It's just not any different from coding with code, other than it's at a higher level language. If you're doing it correctly, if you give it vague prompts, you're going to get vague outcomes, and it'll be terrible code. If you try to make the chunk of change too big, it'll start getting amnesia because you've exceeded the number of tokens they can remember, and it'll start forgetting where it is, and you'll start getting bad results out of that. So but we don't want large chunks of code anyway, right? We want everything to be small and modular anyway, right? So cool. It reinforces that behavior of small modular components.
Makes sense.
And so it's a different, a slightly different workflow. But if you have the mindset you need to do CD correctly, it'll be natural.
Very cool. All right, Bryan, I have a few rapid fire questions I want to go through. I know we are already over time, but hopefully we can cover this.
Sure.
Are you ready?
Yeah, go for it.
Okay, so what areas are you most excited about, like developer experience in terms of evolution in the next few years?
I'm really interested to see what capabilities will make my life easier as people start adding AI capabilities to platforms. Things like getting faster detection of possible defects coming up in the future based off of where we've been in the past, operational visibility, that sort of thing, right? What I predict that we'll have more of those coming, and that platforms that don't contain them will be hurting. So again, it's how can I sleep better at night? That's like my personal. I've got a personal logo that's got Batman with a no symbol, a Batman symbol with a no symbol that says, optimized for sleep.
Very cool. I'm very much looking forward for an AI SRE.
I mean, imagine how much more effective an SRE would be with earlier visibility to potential problems.
100%. Okay,
Yeah.
you kind of like also answered my next question. So I'll moving on. What makes a good DevX engineer?
Yeah, I was just actually talking to a bunch of platform people 2 days ago.
Okay.
It's caring about the people using the tools. That not only are they building tools that are needed, they're not building tools that aren't needed, and they're talking to the people using the tools to find out if the tools are hard to use so they can make them better. It's actually caring about the customer instead of just building tools and throwing at them. And also caring enough to make sure that's documented well. So if you are building a platform where people have to talk to the platform team, you failed. The platform team should be completely invisible. The only time people should know about the platform team is when something breaks. That means good documentation and good customer service.
Very interesting. Okay. What are your favorite tools for developer experience?
Ones that are easy to use. I don't have a list. It's like anywhere you go, you're going to get the tools you get, right? As long as they're easy to use and stay out of my way, they're my favorites. I mean, I use VS Code as an IDE because it was the closest thing I could get to VI. It was just trimmed down. It does what I need it to do and exactly that and nothing more.
Do you use a VI extension on it? Like
No.
the keyboard shortcuts?
No, I'm not a masochist. It's just my point being it's just clean, right? I can put in exactly what I need for what I'm building and nothing else. It stays out of my way. And it's helpful in the way I need it to be. But no, I can use better tools than VI now, so I don't use VI extensions.
Nice.
I used VI every single day for over 20 years. I can do without
it. So, and are there any books that you recommend?
Yeah, there are. Absolutely, Modern Software Engineering by Dave Farley. I think that should be required reading for anybody, especially new hires, but any engineer needs to read that book. It's excellent. Also, engineering the digital transformation, because something that we as engineers tend to suck at is communicating why this is a better way of working to leadership who may or may not be technical and may or may not care about how we work as long as we get the problem done. But they need to care so they can support the effort. Engineering the Digital Transformation by Gary Groover. Excellent book for learning how to do that.
Okay, that's a new one for me. So one question I kind of like forgot to ask earlier. So
Sure.
you mentioned also about like Dojo Consortium.
Yeah.
Do you want to describe a little bit about like how it started, what it is?
Yeah, so back in 2014, Target started the Target Dojo, and it was focused on elevating their teams. They were going directly from we were doing waterfall to we're doing continuous delivery. So they jump started past all the Agile Manifesto and Agile uh, industrial complex crap and went straight to how do we deliver code. And then other companies started picking up that pattern. And at Walmart, we modeled it not directly after Target because we can't go talk to Target because at Walmart. We did model it after Verizon, who modeled it after Target. And it was just and so you had all these large enterprises starting up dojos. Well, the natural thing is for those dojos to talk to each other to compare notes and how do we do this better. And so they created the Dojo Consortium. It was pretty cool. You'd be on a call and it'd be like us and Target, US Bank talking to Capital One. I mean, they had that level of trust that we could help each other with the internal problem. How do we deliver software better? And then one of the things that came out of that was dojoconsortium.org, where there's a whole bunch of playbooks that were used as self-help guides because dojos don't scale. You can't go talk to every team unless you just want to do it the hard way. But how do we push the information out so other teams can help themselves?
I see. Okay, so I'll also link this Dojo Consortium website on our show notes so people can find it and join it, so that people can learn more as well. Bryan, I know we have already taken longer than this was supposed to be, but I learned so much. I'm definitely going back and brushing up some of my basics on continuous delivery. But this was a fun conversation. Thank you so much for your time.
No, thank you so much for having me. And I'm not sure why my alert just went off, but yeah, thank you for having me. And no, it's fun talking about this. I can go on forever.